Hello, this is Mrs. Schroeder. We're back to talk about Chapter 11. This is beginning intermolecular forces. Now, we've talked about some of these things in the first semester. We talked about our ionic and covalent compounds, which we call molecular compounds. Today we're going to talk about what dipole-dipole forces are and how they're formed, why they happen, and also something called the hydrogen bond and what a London dispersion force is. Remember, properties of ionic compounds. Ionic compounds are basically a very strong compound, usually solid, crystals. They have high melting points, high boiling points, dissolve in water, conduct when they're dissolved in water. And why did they do that? Well, it has to do with their ions. Casualty of the ion war. So I'm hit, I've lost an electron. Are you sure? Yes, I'm positive. So when you lose an electron, you become positive. Now you have that charge, which is what gives rise to our melting points and boiling points. When we have that positive charge and we have a negative charge, we have a very strong bond between the two. This gives rise to our melting points of very high numbers, upper hundreds, even in the thousands. Boiling points, basically you're not going to boil these things. Over 1,000, over 2,000 for some of these different compounds. Covalent compounds, some other substances we see. Natural gas, for example. Its melting point is negative 182, boiling point is negative 64. Yeah, it's a gas at room temperature. About 25 is room temperature. Ethyl fingernail polish is a liquid at room temperature. If you look at its melting point, negative 84 versus boiling point 77. So covalent compounds have melting points and boiling points, and they can range from negative 182 to 22 for this one. Why is there this range? It's one of the things we're going to talk about today. So between particles, we have forces. Forces are what holds those particles together, what holds those atoms together. It takes energy to overcome those forces and break those particles apart. Once you break them apart, they can turn into a liquid or a gas. Melting point and boiling point then help us measure the strength of the forces, because if I'm going to boil something, I have to break those particles very far apart. Remember that liquid particles are close together, gas particles are very, very far apart. So ionic compounds have very high forces of attraction because they have that positive charge and negative charge. And those forces between the positive and the negative are very, very strong. They hold those together. It takes a lot of energy to break this bond. It doesn't happen very easily. So you have to put a lot of energy in to break that bond. Even between ionic compounds, there's a difference between the melting point and the boiling point. Part of that has to do with the size of the ions. Smaller ions are closer. The closer they are, the stronger their attraction. So compounds with smaller ions have the highest melting points. And we can go back to our table here. Fluorine is one of the smallest ions. It has one of the higher boiling points and melting points, higher than chlorine. Now we're talking about something called intermolecular forces. Inter means between molecules or between particles, versus intra forces, which are within that molecule. So intermolecular forces are between two different molecules next to each other. These are weaker than the ones in the molecule, so they're not as strong as that bond in the ionic compound or that bond in the covalent compound. Remember when we made our dipoles, we talked about some that had a positive at one and a negative at the other. These are our dipoles that form. Our polar compounds, we talked about having dipoles. They higher electronegativity would tend to pull the electrons towards itself, so it has opposite poles. One pole has this partial positive charge, and the other part and has this partial negative charge when we're doing those signs. Well, if we have that, the molecules will actually orientate themselves to try to match up those sides. So I have a partial negative and a partial positive, and these two want to match themselves up, so they have a force of attraction called an intermolecular force. Now polar molecules have high dipole-dipole forces because they can have this bond, this intermolecular bond between them. The higher the polar compound, the higher the boiling point. Hydrogen bonding is a special case of our dipole-dipole attractions. When hydrogen is bonded to so you have to have hydrogen, you have to have a high electronegative atom, and you have to have two unshared pairs. If a compound has hydrogen bonding, it's going to have a much higher boiling point because hydrogen bonding is a very strong bond. And if you look at this right here, we have a few things. We have our hydrogen right here, one of those requirements of hydrogen bonding. We have a high electronegative, that's my oxygen. And I also have my two unshared electrons are right out here. So when I have those three pieces together, then I can make this hydrogen bond. I can make the hydrogen bond happen between those. And hydrogen bonds form with mainly nitrogen, oxygen, and fluorine. These are highly electronegative atoms that do have those unshared electrons. London dispersion forces are another type of intermolecular force. This happens when electrons are moving because they're constantly in motion. Sometimes they end up more on one side than the other side, and it can be moving randomly. I'll show you this video tomorrow in class, remind me about that. But these London dispersion, because they have electrons are moving, sometimes they end up with more electrons on one side than the other, which creates what's called temporary dipoles. So I have a nonpolar atom right here, and I have the electrons moving, and as they move, now my electron cloud is more negative on this side and more positive on this side. So when I have enough of those happen, they begin to line up, the partial negative and the partial positive, with something else that's a partial positive, and I form this bond between these two. And it's not a very strong bond, it's not a very long bond, it doesn't happen for a long time. It's called our intermolecular, and it's a temporary bond again. Nonpolar molecules can only have London dispersion forces because they don't have dipoles naturally. Our polar molecules can have both of them though, both London dispersion forces and our dipole-dipole interactions. And again, if it has hydrogen, it could have hydrogen bonding. Just to keep straight which ones are stronger, dipole-dipole forces are stronger than London dispersion forces, but they're both weaker than crystals. London dispersion forces are also roughly proportional to how many electrons are present. The more electrons you have, the more you can have this swing and have stronger electrons on one side than the other. So we can figure out which ones have higher London dispersion forces by looking at its molar mass. So the greater the molar mass, the stronger the London dispersion forces are. And we're going to do an activity in class to try to measure intermolecular forces. So again, make sure you have written down those three kinds of forces and understand the difference between dipole-dipole, London dispersion, and also the special case of hydrogen bonding. And make sure you understand what those three things are.